Hi everyone, we are going to run through a couple problems from a good chunk of the lessons before we do our mid-module test. So this video has examples from lesson 3 to lesson 14. Not every single lesson has a video, so just you might have to kind of check through them and see. So this is lesson 3. We're going to go over exercise 3 and exercise 4 again, just in case you struggled with it. So Mason and Laney ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps that Laney ran was 2 to 3. Remember, when you guys are doing these, it's always important you need to figure out what order your ratio is in. So it's Mason to Laney, okay? And then we always want to make sure we know what the ratio is, which is 2 to 3. Okay, so if Mason ran 4 miles, how far did Laney run? We're going to draw a tape diagram to demonstrate how we found the answer. So the initial ratio, this 2 to 3, helps us to set up our tape diagram. So we're going to just do an M for Mason, and we're going to do an L for Laney. Mason is first in the ratio statement, and 2 is first in the ratio. Okay, so Mason gets 2 boxes. Okay, Laney is second in the ratio statement, and 3 is second in the ratio, so Laney gets 3 boxes. Make sure that when you are making your boxes that they are equivalent in size, because this box is the same value as this box. Okay, they're worth the same amount, so we want to make sure we keep them as close to equivalent as we can so that we understand those have the same value. All right, and then if I read the problem, it says Mason ran 4 miles. Okay, this is a total. Totals go at the very end of the tape diagram, so that's going to equal 4. Like I said, it's a total. Totals always go at the end. So then our next step to look at is, okay, how much are each one of these boxes going to be worth? If our total is 4 and we have 2 boxes, we're going to take 4 divided by 2. So again, this 4 is our total. This 2 represents the number of boxes that Mason has. Okay, and then 4 divided by 2 is 2. So 2 goes in each one of those boxes. When you add these, they should equal whatever your total is, okay? So since this box is 2 and this box is equivalent in value, it also is worth 2. This box is 2, this one is 2, and this one is 2. So when you're having these boxes should all be the same value, which means we get 6 for Laney. Remember that in 6th grade year, it gets really important that you guys are answering in complete sentences. So Laney ran 6 miles. Make sure we labeled that correctly, that it's 6 miles. All right, let's take a look at B. If Laney ran 930 meters, how far did Mason run? Draw a tape diagram to determine. Remember, when we're doing this, A, B, C, they are all based off of our initial ratio. That's not going to change, okay? Mason is always going to run 2/3 of what Laney ran. All right, so then we have Mason, we have Laney. Mason was 2. Laney was 3. Okay, and on this one, it's Laney, and she ran 930 meters. So we want to make sure that that's our total. That goes at the end of Laney. Okay, so then we're going to take 930, and we're going to split it evenly between 3 boxes, which means we're going to divide. So that equals 310. So each box is worth 310 meters. Okay, and then again, these are equivalent, so that means this is 310 and 310 for Mason. Okay, and then if we add Mason's total, 310 plus 310 is 620. 620. Okay, so Mason ran 620 meters. We're going to make sure we put the correct measurement on there. Okay, so there's kind of a look at number or exercise 3 for A and B. Okay, we're going to also take a look at exercise 4 really quick. So in case you had any questions on that one when we went over it for notes. Exercise 4, it says, Josie took a long multiple end of the year vocabulary test. The ratio of the number of problems Josie got incorrect to the number she got correct was 2 to 9. So we want to make sure we know it's incorrect to correct and that our ratio is 2 to 9. Always remember, those are the first things that we are identifying every single time. Okay, if Josie missed 8 questions, how many did she get correct? Draw a tape diagram to represent. So we're going to use our 2 to 9. Incorrect is first. So we're going to write incorrect. And that's 2. It's first in the ratio. So we're going to draw 2 boxes. And then we have correct was second in the ratio statement. So we are going to draw 9 boxes because it's second in the ratio. So okay, so now we have 9 boxes. If Josie missed 8 questions, so missed lets us know that she got them incorrect. So she missed 8 questions. We're going to put that 8 at the end. Okay, how many did she get correct? So now we have our total is 8 that she got wrong. We have 2 boxes, so 8 divided by 2 equals 4, which means a 4 goes in each one of those boxes. So then for correct, 4 would go in every single one of these boxes. Okay, so 4, 8, 12, 16, 20, 24, 28, 32, 36. So we're going to write our sentence. Josie got 36 problems correct. Okay. All right. B says if Josie missed 20 questions, how many did she get correct? Draw that tape diagram. So again, we're using the original ratio because that didn't change for our problem. So we still have incorrect to correct. And their ratio was 2 to 9, so it's 2 to 9. Okay, and then if we read the question, Josie missed 20 questions, so that would be incorrect. So she got 20 wrong. So 20 divided by 2 is 10. So 10 goes in each one of those boxes, which also means 10 will go in each one of these boxes. Okay, which is 10, 20, 30, 40, 50, 60, 70, 80, 90. So Josie got 90 problems correct. Okay, so there's kind of our examples in case you struggled with lesson 3. Okay, you can kind of use those as your examples for that. All right, lesson 5, we're going to look at example 3 and 4. Those are the ones that we didn't do in class, so this gives you a chance to look at some new ones that maybe you weren't quite sure of. as we are going through it. So we have Miss Johnson and Miss Sipple. We're folding report cards to send home to parents. The ratio of the number of report cards Miss Johnson folded to the number of report cards Miss Sipple folded is 2 to 3. Remember, the very first thing that we always identify is what is the order of the ratio and what is the ratio. So we have Miss Johnson to Miss Sipple, and our ratio is a 2 to 3. Okay? So at the end of the day, Miss Johnson and Miss Sipple folded a total of 300 report cards. Total is super important because that lets us know where are we going to put our number and then where are we putting this 300. All right, so we're going to create our tape diagrams. We have J for Johnson. We'll just do S for Miss Sipple. Okay, Miss Johnson is first in the ratio statement, and the 2 is first in the ratio. So Miss Johnson gets 2. Miss Sipple is second in the ratio statement, and the 3 is second. So we're going to make sure this is 3 boxes. We know that this is a total. Okay, so that means both of these teachers together, because it says at the end of the day, Mrs. Johnson and Miss Sipple folded a total. Both of these teachers together folded 300 report cards. Okay, so when we're looking, we are now going to take 300, our total, and we are going to divide it by 1, 2, 3, 4, 5, because that's how many boxes that we had. Okay, so we're going to have 300 our total, divide it by 5, which is our number of boxes, just in case you forgot. So 300 divided by 5 is 60. So each one of these is 60. Remember that each of the boxes are equivalent. They have to have the same amount in them. Okay, so now the question is, how much did each person fold? So Mrs. Johnson folded 120, and Mrs. Sipple folded 180. And these two numbers, if I added them together, should equal 300. So, and then we definitely want to make sure we write it as a sentence. So, oops, I guess it's Ms. So, Ms. Johnson folded 120 report cards, and Ms. Sipple, make sure I spell it, yep, folded 180 report cards. I'm sorry I smushed that in on you guys, but there's your answer for number 3. Okay, all right, let's take a look at 4. Okay, 4 says at a country concert, the ratio of the number of boys to the number of girls is 2 to 7. Okay, so again, find the ratio statement. What's the order? It's boys to girls, and the ratio is 2 to 7. Okay, if there are 250 more girls than boys, how many are at the concert? So in this one, we have 250 more. Okay, that word more is important. That tells us how we're doing it differently. Remember, in this one, it was a total. Okay, in this problem, it's a more problem. So we're going to do boys to girls. The ratio is 2 to 7. Boys was first, so they get 2. And the girls are 7. And they were second, and 7 is second in the ratio. Okay, and if you look, we obviously have more girl boxes than we have boy boxes. So that makes sense that there are more girls than boys. Okay, when it is a more problem, right, you have to discover where the more boxes are. We have 5 more boxes right here. These are the extra boxes. Okay, so what that tells me is that the 250 more has to be divided equally among those 5 boxes. Okay, so since there are more boxes here, this is 250 more, we want to do 250 divided by 5, okay, which is 50. So each one of these boxes is 50. And if we look, that equals 250. There's 250 more girls than there are boys. If these boxes are 50, all the rest of these are 50. Okay, and I'm going to highlight just so you guys kind of see it again. Like, these were the more boxes. So there were 250 more. All right, so it wants to know how many boys. We have a total of 100 boys. So 100 boys were at the concert. Okay. All right, we are in lesson 6 for this problem. We are going to look at number 5 on our notes, and then we're also going just to review that exit ticket one more time. We didn't get to number 5 in the notes, so that's why we're going to look at it right now. So at the beginning of grade 6, the ratio of the number of advanced math students to the number of regular math students was 3 to 8. So we have advanced math to regular math, and it was a 3 to 8. This was at the beginning of the year. Okay. However, after taking placement tests, students were moved around, changing the ratio of the number of advanced math. Let me grab a different color so you guys can see it better. Okay. The number of advanced math to regular math was now 4 to 7. Okay. So what we're doing in this is we are comparing the before the pretest and then the after the pretest kind of assessment that was taken. How many students started in regular math and advanced math if there were 92 students in the advanced math class after? So we had 92 students, advanced math, and after. Okay. All right, so we are going to compare. One thing with the comparison to make sure, if you notice, this is a 3 to 8, which would be a total of 11. This is 4 to 7, which is a total of 11. For us to be able to compare them both, that total number still has to be the same. We can have different ratios, but we need that total to be equivalent. So we have the beginning. So we're going to just write beginning. Okay, and then we have after. Give yourself some type of label, beginning, after, first, second, something that can help you kind of organize those out better. So in the beginning, we had advanced math to regular. So we're just going to do A for advanced and R for regular. And the ratio was 3 to 8. So 3 to 8. Smush that last one in there. Okay. And then for the after, which was our green, we had advanced math to regular. And it was a 4 to 7. Okay. So then we need to read kind of the rest of the information, okay? How many students started in regular math and advanced math? That's the answer to our question, okay? If there were 92 students in advanced math after the placement test. So we want to go to our after graph, okay? We want to look at, it says 92 in advanced, which means 92 is our total for our advanced students, okay? And then we just need to figure out how many goes in each one of these blocks. Because it's proportional, okay, the number that's in this box is the number in this box, is the number in this box, is the number in this box. So as soon as we figure it out for one, everything else is just repeating the rest. So for this problem, we would take 92, divide it by 4, and 92 divided by 4 is 23. So each of these boxes are 23. Each of these boxes are 23. Oop, 23. Each of these boxes are 23. And so on. So that's the nice thing about these tape diagrams, is once you complete it for one, the rest are all the same. You do want to make sure you divide correctly, guys. If you don't divide correctly, then you could end up with a totally messed up answer. All right, so if I want to figure out the advanced math, I would add these up, which would be 69. And then the regular math, if I add those up, would be 184. Okay, and I just realized I didn't write the original ratio in, which is something I made you guys do when we did notes today, so I'm just going to write that in real quick. Okay, and then the question is, how many students started in regular math and how many students started in the advanced math? So it just wants this side because we want the how many kids started. So there were 69 students in advanced math. Make sure you're checking that label and you're writing the correct label with the correct number. And 184 students in the regular math. Okay, so that's how, when we are comparing two different ratio sets, how that's going to work. Okay, I'm going to also do the exit ticket with you guys, just so you guys can see the exit ticket for lesson number 6. So students surveyed, boys and girls separately, determined which sport they enjoyed the most. After completing the boy survey, it was determined that for every 3 boys who enjoyed soccer, 5 boys enjoyed basketball. Okay. The girl survey had a ratio of the number of girls who enjoyed soccer to the number of girls who enjoyed basketball, 7-1. So theirs was a little bit different. Theirs was the girls were soccer to basketball, and it was a 7-1. Okay. Again, if we look, this is a 3-5, which is 8. This is a 7-1, which gives us a total of 8 as well. If the same number of boys and girls were surveyed and 90 boys enjoyed soccer, how many girls enjoyed each sport? Okay, so that's the question we want to answer. This information is what we're going to use to help us solve it. So we are going to divide this into boys and girls. Our ratio for our boys is 3-5. And our ratio for our girls was 7-1. Okay, and it was, for both of them, it was soccer to basketball. So here's soccer, here's basketball. So there's 3 for our first one and 5 for our second one. Okay, and then for our girls, it was a 7-1. Okay, it was soccer to basketball. So 7-1. Okay, so there's both of the 2 ratios set up as a tape diagram. So now we're going to look, we have 90 boys enjoy soccer. So we're going to go to boys, we're going to go to soccer, it's going to equal 90. So we're just going to take 90 divided by 3, which gives us 30, which means every single one of these is 30. Okay, and same thing over there. All of these get to be 30 as well. Which means there are 30 girls who like basketball and there are 210 girls who like soccer. Okay, which gives us the same total. And if we looked over here, this is 30, 60, 90, 120, 150. Okay, if we added 150 plus 90, that's 240. this is also 240. Okay, it works because we ask the same amount of people for our things. So if this was your homework, we would write out a sentence for the exit ticket. We are going to look at a problem from lesson number 8. Lesson number 8 is actually really simple, except for the very last problem on your homework is confusing. So what I've done is I've created a problem that is similar to it so that you can use this to help you answer the question for your homework. So PTS 6th grade has 1,500 students. We have a lot of 6th graders. 2/5 of the students buy their lunch. What is the value of the ratio of the students who bought lunch to those who do not? So one important thing to recognize in this problem, when we get to lesson 8, we're learning what a value of a ratio is. Okay? And anytime we see value of a ratio, we are writing our answer as a fraction. Okay? So that value of a ratio lets me know I am writing my answer as a fraction. All right? So to do this, there's a couple different ways. I have found that the easiest way to do this is to go ahead and create a tape diagram. So we know that it's 2/5 of them have buy their lunches. So we know that we're going to have 5 equal sections for our tape diagram. Okay. We also know that 2/5 of it buy their lunch. Okay. So this is our buy lunch. Okay. And this is our bought lunch. Excuse me, vice versa. Brought. Okay. So these are our sack lunch kiddos right here. Okay. Right there. So if we look at this, okay, what we kind of need to figure out is this is 1,500 students total. Okay, so there's 1, 2, 3, 4, 5. So we would take 1,500 divided by 5, and each one of these would be 300. So 300, 300, 300, 300, 300. Okay, so when I have it, okay, we're going to look at, our question is ratio of students who bought lunch to those who did not. Okay, so there's 2 different ways that you guys can look at this problem at this point. We can go ahead and do our buy, which would be 600 because it's who bought to who didn't. 600 over 900. Miss Brian can add. Okay, I almost said 1,200 there. All right, so we have 600 and 900. We know in life that we always reduce our fractions. We don't leave them like that. So if I was looking at this, I haven't if we look at this problem, okay, and we want to reduce this, we know that 300 can go into 600. We know that it can also go into 900. Okay, 600 divided by 300 is 2, and 900 divided by 300 is 3. Okay, that's if you want to look at it numerically. But guess what the easiest thing to look at is? How many greens do I have? I have 2. How many blues do I have? I have 3. So 2/3 is our value of our ratio. Okay, so when we're looking at that value of the ratio, it's 2/3 for our answer on here. Okay, so there's kind of 2 ways you can look at it. If you want to do numerically and then reduce, or if you just want to go ahead and color code this out, it's our buy. We have 2 boxes that bought to 3 boxes that are bringing their sack lunch, so it's 2/3. All right, lesson 12 is taking ratio tables and turning them into double number lines. So on your notes, we already have this part filled out. I'm just going to review exercise number 3 that we did in class, and then I'm also going to review exercise number 4 that we also did in class, just so you have a second chance to look at it. So if we look at number 3, it says a 1 liter bottle of cola contains 34 fluid ounces. Okay, and if I went to go look at my table, I don't have 34 on here. I'm also not ever going to get to 34 if I increase my table proportionally. All right. My next number is 24, and then I get 30, and then I'm going to get 36. So I can't find 34 within the table if I used a ratio table and increased proportionally. So we want to know how many grams would be in that 1 liter. Okay. So what we use is we use the double number line. When we're using the double number line, we want to go ahead and label. So our top line is cola. We also want to make sure we tell what we are measuring in. So on this, we measured in ounces. So it could be liters, it could be cups, whatever it happens to be. And then we're going to do sugar. And we are measuring in grams. Okay? And all I did was I took our table, cola in ounces, sugar in grams, okay, and I put those exact same labels on our double number line. Okay, the double number line always starts with 0. Okay, and then we're basically going to create this table on here. So we knew that based off of our table, in 6 ounces of soda, there were 20 ounces of, or 20 grams of sugar. So this first one is going to be 6 for our cola and 20 for our sugar. Okay, our next line, we are going to increase proportionally. So this is going to increase by 6. So this is going to go to 12. This is going to go to 40. And then increase again. And we're going to go to 18 and 60. And I'm going to continue to proportionally increase these. Okay, and then we have 30 and 100. All right, and then lastly, we're going to do 36 to 120. Okay, we don't have to continue on our double number line because we're looking for 34 ounces of soda, and it's going to fall between 30 and 36. So we know that it's going to fall somewhere within that range of data that we have. So your next kind of step is, okay, I'm only going to focus on this little piece between 30 and 36. What can I count by that is going to give me 34? Because 34 is our magic number. Okay, so 34 is what we want to get to. So we could count by 2s and go 2, 4, 6. So 30, 32, 34, 36. Okay. If we counted by 3s, we would go 30, 33, 36. The problem is we still didn't hit 34, and we have to hit 34. Okay, so we have to think, all right, what can I count by that's going to start at 30 and end at 36 and give me what I need. So for this particular one, we went ahead and we did 1. So we did 31, 32, 33, 34, and I'm going to squish this in here, 35. Okay, so this is 31 ounces, 32, 33, 34, 35, and then this last line is our 36. Okay, so we had 34 ounces of soda. So this line right here is kind of our important line that we're working with. All right, so you have to find the distance between these two numbers. Okay, so we have 120 and 100. So if we took 120, actually, I'm not going to write that yet. Okay, so between 100 and 120, there's 20 grams of sugar in here. Basically, all we took was 120, we subtracted 100, and that's how we got 20. Okay, our next step is, okay, how many sections do I have? There's 1, 2, 3, 4. Okay, so we are going to stop right here because this is 34, so we get to stop at that last little section right there. Okay, so we have kind of added this piece in here. From 30 to 36, there's 6 sections. So actually we can write in the 5 and the 6 so we can see. Okay, there's 6 sections. Okay, 34 is our 4th section. Okay, so if we look, let's do it in green for you. Okay, actually I'm going to do it in blue because we're already kind of in blue. So here's 1 section, here's 2, here's 3, here's our 4th section. Okay, so it stops at 34 at this 4. Okay, so our your sections are your lines, just in case you're wondering. Okay, so our fraction is 4, 6. There's 4, 1, 2, 3, 4 sections before we get to 34 out of 6. That's this whole kind of chunk right here. And this reduces down to 2/3. Okay? So now what we're going to do is we know that this is 2/3 of this chunk right here. It's going to be 2/3 of 20. So we're going to take 2/3 times 20. Okay. We don't multiply whole numbers times fractions. So we need to write this as 2/3 times 20 over 1. Okay, we always put a 1 as the denominator because it doesn't change the value, which equals 40 over 3. That's an improper fraction, so we're going to turn it into a mixed number now. So we are going to take 40 and divide it by 3. It goes in once. Drop that. It's going to go in 3 times. Okay, because we're working in fractions, we get to end in fractions. So this, when I multiplied 2/3 of 20, okay, I got 13 and 1/3. Okay, so all that's telling me is that this blue is 13 and 1/3 grams of sugar because we took 2/3 of 20. Okay, remember 20 was this whole section, but we didn't use the whole section. We only used 2/3 of it, right? So for your final answer, when you guys did this, okay, you would consume 113 and 1/3 grams sugar. Okay, and we got 113 because this is 100, okay, and then we had 13 and 1/3 more. So we took the 100 plus the 13 and 1/3, and that's how we got 113 and 1/3 grams. Okay, all right, we'll do another one. These are a little tricky. They can be hard. Okay, so let's look at exercise 4 again. Okay, a school cafeteria has a restriction on the amount of sugary drinks available to students. Drinks may not have more than 25 grams of sugar. Based on this restriction, what is the largest size cola in ounces the cafeteria can offer students? Okay, so if we looked again at our table, we go 20 and 40, which means we don't have 25 grams on there. So we need to create a double number line so that we have 25 on there. So we're going to do example 4 just right down here. Okay. Again, we're going to fill out. We have cola, and we have that in ounces. and we have sugar, and we have that in grams. Okay, we always start double number lines with zeros on the left. Okay, so we know that we have a 6-ounce cola has 20 grams of sugar. Okay, and then we know a 12-ounce cola has 40 grams of sugar. Okay, but in this particular problem, 25 grams of sugar is our number. So we're trying to figure out where 25 grams of sugar is going to fall. So we need to look at our sugar. What can we count by to get from 20 to 40 and hit 25? So we could count by ones, but that's going to be a lot of spots. If we count by twos, we have 22, 24, so on. So 22, 24, 26. Did we say 25? No, so we can't count by twos. Okay, if we did threes, we're not ever going to get to 40 counting by threes. We're going to miss it. All right, we could do fives, 25, 30, 35, 40. Okay, so on this one, we're going to count by fives. So we're going to have 25 grams and 30. Oops. I need to move this over more. We're going to have 30 grams, and then we'll have 35 grams. Okay? And then we get to 40, right? We have 1 section, 2 sections, 3 sections, 4 sections. Okay? We are going to 25, so that's how far we need to go. Okay? So in this graph, okay, we have 1/4 of it, okay, is shaded in. Okay, so that's where we're getting 1/4 of our graph. So we're going to have 1/4 times something. This 1/4 is 1/4 of the graph. Okay, that's coming from here. There's 1 section out of 4 that are shaded in. All right, so now we need to figure out what we're going to multiply it by. Well, it's based off of this number. So how many ounces are between 6 and 12? Okay, there are 6 ounces between 6 and 12. Okay, so we're going to multiply it times 6. We don't multiply those fractions times whole numbers. So it's 1/4 times 6 over 1, which is 6 over 4, okay, which is the same as 1 and 2/4, but we always reduce, and we get 1 and 1/2. Okay, so we know that each section is going to equal 1 and 1/2. Okay, so if I had 6, if I'm going to add 1.5, that would be 7.5. All right, so the answer for this one is that the school can offer up to 7.5 ounce sodas. All right, lesson 13, we are just going to look at exercise number 4, making sure that you guys can create those different equations based off of the table that you are given. So during a particular U.S. Air Force training exercise, the ratio of the number of men to the number of women was 6-1. So men to women, 6-1. Okay. Use the ratio table provided to create at least 2 equations that model the relationship between the number of men and the number of women participating in this. So when we look at our table, we're starting with women. Our ratio is men to women, 6-1. Women was set second, the 1 is second. So the first number in our table has to be 1 because that's what our women was. And then our men would be 6. Okay, so then we can create the table proportionally. So remember, we're just adding. We started with 1, so we just add 1 each time for the women. For the men, we started with 6, so we are going to increase by 6 each time for the men. Okay, and 30. So there's our table. Now what we have to do is we have to create the table. Okay, so we can look at our ratio of women to men. So if we did women equals, okay, if I have women, how am I getting from here to here? Okay, I'm taking 1 times a number to get to 6. So our women, okay, I'm actually going to rephrase kind of what I started to say to you guys, because we're doing what the women equal. So the women is less than the men. Okay, so which means if we want a number less, we're going to have to multiply by a fraction. All right, so our women is 1/6 the amount of men that we have. Okay, so it's smaller, so it's going to be 1/6 the amount of men. If we were doing the men, okay, and trying to get to the women, okay, the men is 6 times larger. So we have 1 woman to 6 men, okay? So our men are 6 times larger than our women, okay? So it can sometimes be a little confusing because we want to look at this table and go, oh, it's women is 1, so we're going to take 1 times 6 to get the men. But we're taking the men and multiplying it by something to get the women. Okay, and so we're taking the men, multiplying by something to get the women. It's smaller, okay? It's 1/6 the amount. Whereas if I was taking the women and I want to multiply it times something to get the men, I would have to multiply by 6 to get the men. Okay, so then we have, if 200 women participated in the training course, use one of your equations to calculate the number of men who participated. So you could use either one. If we used the men equals 6W, okay, all we're going to do is we're going to substitute in things correctly. So we have 200 women, okay, so this 200 has to go in where the women is. So we don't have anything for men. We have 6 times 200 because there's 200 women. Okay, and then if we multiplied that out, we would have men equals 1,200. Okay, anytime you guys see calculate, okay, that just means like find the answer, so on, and we want the number of men as our final answer. Okay, let's go ahead and take a look at, actually that's the last one we're doing for that one. All right, the last lesson that we're going to have before we get into our mid-module, which is going to be right after lesson 15, is lesson 14. So lesson 14, we talked about taking ratio tables, creating equations, creating double number lines, and plotting them on a coordinate plane. So you're taking everything that we have learned how to create and basically doing it in one assignment. So we're going to look at our exit ticket. Dominic works on the weekends and on vacations from school, mowing lawns in his neighborhood. For every lawn he mows, he charges $12. Complete the table, then determine the ordered pair and create and label a graph. So you've got a couple things. You've got to complete the table, you've got to do the ordered pairs, and you have to create and label the graph correctly. All right, so for every lawn he mows, he charges $12. So for every lawn, he charges $12. So that ratio is a 1 to 12 ratio. So on this one, he mowed 2 lawns. Okay, so this would be 24. Okay, then on this, he did 4 lawns. So we kind of doubled our 2 to our 4. So we're just going to double this right here. Okay. And then we're going to continue on our table. So this is 72. Make sure you don't, this is where we struggle. Sometimes we go, oh, okay, I'm going to double again and double and double and double. We're increasing proportionally. So we had 2 to 24. We increased by 2 here. So we have to increase by 24. We increased by 2 here. We have to increase by 24. We increased by 2 here, so we're increasing by 24. So be careful. I accidentally kind of said that you should double it. It always works in the first 2 lines. It doesn't work after that. So I apologize for saying that and messing you up. Okay? All right, your next column is to fill out the ordered pair. Okay, when we do the ordered pair, the X is always first, followed by the Y coordinate. Okay? When we have a table, the X is always the first section of the table and the Y is always the second. So it's kind of nice. All we have to do is put this in order. Make sure when you guys are making your order pairs, it's 2, 24. I need to see it nice and clear, and I need the parentheses. This one would be 4 and 48. This one is 6 and 72, and so on. Okay, if you don't put that comma in there, you've got some really funky numbers going on. So there's our ordered pairs. Okay, then we want to create and label our graphs. Okay, you guys typically will mess up putting the right things in the right spot and labeling correctly. Okay, our lawns is our X. We already talked about that. Okay, this is the X axis. Okay, which means it has to be talking about the lawns. So when I label my x-axis, I'm going to write number of lawns because my X is first and it's lawns. This is my y-axis. It's going to be the Y topic, which is charge in dollars. So I'm going to turn my paper to the side. I'm going to write charge, and I'm going to put in parentheses dollars because we want to make sure we label this. If I was talking about cups of orange juice, I would want you to put cups. Or sugar, are you measuring in ounces? Are you measuring in cups? Whatever you're measuring in, okay? So then the easy part now is we just get to go through and decide. We can basically kind of follow this number out. The X's have to be the same and be consistent. Okay, I'm not going to go 2, 3, 5, 9, 12. I'm going to count by a consistent number. So I'm going to go 2, 4, 6, 8, 12. Okay, and I'm not going to go 2, 4, 6, 8, 12 because I forgot 10. It's late tonight. All right, and 10, 12. Okay, all I did on this is I skipped a line and then did 2, skipped a line and did 4. If you're going to do that, just make sure you do it consistently. You don't start with 2 here and then skip a line 4, skip a line 6, and so on. You want to make sure that's a consistent changeover. And then we're going to kind of do the same thing. We're just going to count it off by this because its numbers will fit. So 24, skip a line 48, skip a line 72, skip a line 96. Sometimes this just helps our graph not look quite so full of information and things like that. Okay, and then your next task is to graph it. So we have 2 and 24. So we start at the origin, we go over 2 on the X, up to 24 on the Y. Okay, the next one is 4 and 8. So we start at the origin, we go to 4, and then we go up to 48. Then we have 6 and 72. So we start at the origin, we go over to 6 on the X, and up to 72 on the Y, and kind of repeat that same process. Okay, and our last one is 10 and 120. Miss Brian almost messed that one up. There we go. Okay, one thing that when you finish, you should be able to draw a straight line through these coordinates, at least pretty close, okay, and go straight into the origin. If this is not on a straight line, you did something incorrectly, because ratio tables are linear equations, so they're going to create a linear line because they increase proportionally. Okay, I'm not going to go over answering the questions on here because that's not really something you need for to be able to do your homework, but I just want to quickly show you, remind you, how do you turn this ratio table into a double number line. So we're going to kind of just flip our paper over, okay, and create our double number line. Okay, remember it always starts on 0. Okay, when we're looking for this label, we're going to do number of lawns because that's the X. So it's going to go first. And then we're going to do the Y, which is charge in dollars. So charge, you can do cost, whatever it works, but make sure we put that dollars so we know that we're not charging in pennies or nickels or dimes. Okay, so there's kind of our double number line original setup, and then all you would basically do is put these on here correctly. Okay, so for every 2 lawns that he mows, he makes $24. And then our next line, we're going by 2, so we're going to increase by 2, which would be 4. We increase by 24, which is 48. Increase by 2, so 6 and 72. 8. We're increasing by 24, remember? So we're going to increase to 96. And then we have 10 and 120. Okay, so just in case you forget how to make those double number lines, because you'll need to do all of those different pieces on your homework. One other tidbit for your homework, okay? This is 1 point. This is 2 points. Having the correct label is 3. Having the correct numbers are 4. Having this plotted correctly is 5. Okay? Having a correct double number line is 6. Okay? So these problems, although they're pretty small, add up really quick in points. So just make sure you guys are doing all of the different pieces for that. Okay? You have lesson 15 we're going to do next, and then you guys have your mid-module test. So if you haven't started to look at the mid-module study guide online, that might be your next step to start looking at some of those problems.